Hello, we will try to do this exercise. I'm not really qualified to do it right now, but with some memory and some notes I hope I will be able to solve it. And I'm probably going to make mistakes, and please point them out and I will do a pop-up or something. Now we just try to start with that. So I have my friend's values, which I'm going to use now for the first time. Just try to remember it. Then I'm going to do it with my, maybe not in video, but with my own numbers, because we all have different numbers, slightly different numbers. So you see the question here: determine a suitable thickness for the slab shown below. Calculate the significant design bending moment, positive and negative in every direction. Propose a reinforcement layout. And the L, as you see here. So my L will be this distance here, 8.05, as I said before. So we're not going to use that. We're going to do 7.21, which is okay, which is nice. And then this, as you see here, it's 5.21. So the first, we just got to start out with this thing, which I have no idea why, but apparently the thickness is equal to this length, 7.21 divided by 30, and the 30 number I have no freaking idea, and I asked my friend and he had no idea either. This is not how you should do physics or any sort of math, because if you don't understand it, you just forget about it. And probably this number just feels like they shouldn't be a steady number. Like sometimes there are constants, but just feel like an extremely strange constant. And why the height? Why this and not this? I don't know. I assume it's because of it's long. I remember something as being longer, but anyways. So that's what we did for this example, which apparently was right. So you have 7.21 divided by 30. It's 0.24. So that would be the thickness of the concrete slab. Just gonna. It's a bit laggy, to be honest, with the recording, so it was a bit off. So I gotta erase that. Okay. So with that in mind, I'm gonna continue. So then, the second step would be. Okay, so now I remember. So first, I'm just gonna write it down here. So first we have thickness, and then we're gonna calculate the relation between the lengths and the widths, right? So relation. So it's Ly divided by Lx divided by Li, because the Ly is long, the Lx is longer, and the Lx and Ly is the x direction and the z direction. Maybe when I think about it, should probably it could be correct. Okay, so the relations here, it's because the L's are a constant. That means that the the relationship, no matter what numbers you have, given this formula, obviously it would be 1.4. So this relationship is important because this is related to, you need this for a table. And also one thing, this actually I remember, is that this table, so with this number, you have to do the, you have to go and find, sorry. In this table, it also depends on what kind of supports there are. For example, if there is like this, so the x would be this fixed supports, while the this would be non-fixed supports. So in this case, it would be one value, and there will be 1, 1.2, 1.4. This relation is right here, right? So. And there you get certain values, so MCY, MCX, and you would get different values. Obviously, this should be here. This should be here. What the fuck? This should be here, and you get the blah 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 blah. Okay, different values. But that's for this one, right? But this was not clear for me at first. But what this is, there's no fixed supports anywhere because it's not located. If it were, it would probably be located, at least in our examples. So what this is looking like this. So it's non-fixed everywhere. And there are also some there are like fixed just here, fixed here, and fixed here. A bunch of different ones. So let's find the But if you, like us, have these tables, then and there's long tables, and you also use the same profiles, etc. And you know, this is a part of a document. You know, it's so easy to just make a snipping tool thing and just copy it out. So now, because we were allowed to use a computer for finding these documents, I just did a copy of this like 28-page document and just copy it and save it, and also write down here. So you should divide this by 100 if you're doing the calculations, because you want it in meters, and this is in centimeters. And so, you know, 73 would be 0.03. And here you see, so for us then, so if this is the 1, 2, 3, 4, 5, 6, apparently no, this can't be true, or could it? Let's see, yeah, 1.4, yeah, oh sorry, so yeah, exactly. So let's, okay, so we will take this value, so 1.4, and we'll take this value because it's like this. So then you see 73 and 44. You remember it, so you write down 73 and 44. So that's MCX, MCY. And you know, divided by 100 would be, we're going to see, I've said before, and 40, oops, almost made a mistake, 44. Okay, I remember I made a pretty big mistake, forgetting a part of the exercise, the given values. So I was like, what should I do next? I realized, well, I should probably calculate out the weight, but then I realized we don't have, normally we have you know, roof slabs and shit like that, you know. Okay, so the finishing materials, that's the dead load, and the snow load would be that one. And apparently the safety factor for dead loads would be 1.35, so multiply by that, and the snow load will be 1.5. We're just going to double check that too. Yes. So you take, you know, this 3.5 times this, and this with this, which, you know, it's going to make it very quickly. 1.5, 1.35 times 2.5, 4.725 and 1.5. So that would be 6.22.5 per kilonewton per. Oops, sorry. Kilonewtons per squared, right? And cool. And what else? So not only that, we have that, but we also have the weight of the slab itself. So that would probably be, I'm just gonna. So we know that from this is also given value. This actually, I remember, it's not. Yeah, it's D. It could not also be D. Okay, so this is the now if you want to calculate how much force it's this could, I'm not 100% sure on. I mean, I know more or less what it's about, but I don't know the wording, because I probably make a mistake. It's 25 kilonewtons per square meter, right? So then I assume we're gonna have the length times the height. No, probably not. Sorry. Okay, so this now I realize what it's. So no, that's not what we're gonna do. We are gonna do. So we have the thickness here. The thickness, because this is, you know, this is per linear meter, I assume, right? Fucking, this is what I don't know. So it's 0.24 times the FCD, which this one, so that would be 8.1. Actually, not 8.1, but I think my friend rounded 0.24 times 25. What the fuck? How can you do that? Okay, I'm stupid again. So he did not make a mistake. I did a mistake, and also obviously it's dead load. times 35. So that would be 6 times 1.35 equals 8.1. Adding that, so 8.1 is gonna plus this. Okay, that was not nicer. 6.22.5. That's equal 14.325. Same value he got. Yes, correct. And so now with the kilonewtons per square meter, right? Okay, so now when we have this, we continue with the. Okay, so now that we have this value, we run it to 14.3 for the future calculation, and now we have that. Now is the time that we use these values. So the x goes in this direction, and the y goes in that direction. Or I mean, this is the axis point, right? So then we take mcx. So now we want to know. Let's see. I'm a bit curious why it should be always the same. Okay, I'm not sure if if my logic is a mistake here or not, but I would assume that if you want to take the x direction, you would take this one, while the other one would be that one, but they only took the shorter one for both. I make so many mistakes. My friends is not 0.1 is 15. Again, I would assume that they would take this value when it's mcx, and mcy would be that value. That's what I assume. But what they did was they take mcx times this 14.3 times L. Let's call this L12 square. Okay, that's 12 squared for that one. And if you remember, so it's 0.03, and in the other case, let's switch colors. mcy times 14.3 times, because the load is everywhere, right? So that makes sense. And EB squared. That's what I would think, but that's not what they did. They took this for L12. So for the future reference, I'm gonna make that. Actually, maybe I'll probably ask the teacher next time if this is actually a mistake. Okay, so I just did that. Yeah, it feels like it should be more correct, more logical that way, but okay, we're just gonna continue with calculations. Why can't okay. So 0.044 because that's what they did. So mcx times loads times L12, that would be 0.033. Actually, that's actually not mcx. Well, we're getting mcx, so mcx is equal. This is just what we multiply with this factor. 0.03 times 14.3 times, as we see here, this one, 5.15. 5.15. Let's take the other one and also for mcy we get the same, but 0.044 times the same, which is again squared as well. And this is what I think is wrong. I would assume it's going to be this one, because that's in that direction. Actually, this one should be in that direction, while the other one should be, I think that should be 7.21, but I don't know. Yeah, maybe I shouldn't say anything. Okay, so we're gonna start with that 5.115 because it's easier to erase later in the calculator. times 14.3 times 0.03, and that first one is equal to 27.69, and the other one, oops, that's not how we do it, 0.44 is equal to 16.7. Cool. Now that we have these values, I will continue, of course, and now I have to do a separate bracing for separated parts. So kilonewtons per meter, kilonewtons per meter, and then apparently there's a formula which is USX is equal to, this is just it's just crazy, and they take 16 point, okay, they run a wrong number, but I'm gonna use their number, so they use 16.6 divided by so 0.9, which apparently is a given number, times C, which is the thickness that we got from before, and minus 0.03, and you get USX, which is just, again, this is a bit sad, but I really don't know. And this value, and what I do know is that this value is used for how much, maybe how much force per, no, it's a bit strange. Okay, so this is anyways how much, this is at least for calculating how many bars there is. So let's try to use this number. So again, we said that this was 0.24, which is the thickness of concrete slab, and that would be, you know, so you have 0.20, so 16.6 divided by parentheses 0.9 times 0.21. Made a mistake somewhere. So equals to 87.83. Yep. And okay, so the reinforcement apparently is USX times area of a certain diameter, which is a diameter of the bar, times, let's try to get it, so remember, instead of looking at the notes, times, come on, I can do it. Okay, so this also is a strange part, 28 is a apparently given value, and it's again better way to learn, understand something. But okay, but then when we have, and apparently also the bars, nice bar, the diameter is, you should usually use diameters with 8 to 20, and apparently we should use, we should use these. So apparently you should just take a number and you calculate how many of these bars you do, and probably it didn't matter so much, at least for our calculations, if we use a bit thicker or a bit thinner. It just mean that you require different amount of number of bars. So we'll use 10 for this example, and so we take 87.8 times 10 times 28, which is a very high number. Why do we use that? Okay. Oh yeah, how stupid am I? That's not how you do it. Okay, so okay, so yeah, this is what we, this part is true, but this is what we do later. So we have 87.38 here, and then we take 87.8 divided by 28, and we get the area of this one, and then when we have that, we take out the diameter of it. That's fine. So that's 3.1, and if you remember the formula for circular area, that would be pi. That's not pi. This is just hilarious. That's pi times R2 is the formula. So with that in mind, we and now this is when you use the diameter of it. So we use a 1 of 10 as a diameter, and obviously the radius is 2 radius is a diameter, and obviously so that would be 0, that would be 5, and that would be in something, and it's not 5, but it's 0.5. Oh, God. Embarrassing. So that's what we use for this value. So P times 0.5 raised to the second will be equal to 0.715, and this, and then we take 3.1 divided by 0.785, so 3.1 divided by is equal to 3.95. I think my friend doesn't know how to round. Everything that should be run upwards is run downwards. But okay. And apparently, so that is more or less 4. So apparently you take +1. And +1 is probably, again, this is what I understand least everything. I'm just trying to assume that this is how many distances really you need. So if you have 4 distances, 1, 2, 3, 4, you actually have 1, 2, 3, 4, 5 bars, because you need to close the right. So that's how I try to think about it. I just sum it up now. Okay, so now we have the and also so now when we have that, we also, this is probably not what it should be. Okay, so then now we have the number is 5, then we do 1 divided by 5 is 0.2, so 1 bar every 0.2 spacing, and so that we write here, so diameter 10, 20, so should probably be 20 centimeters. So that's why, that's what I mean. That's like I assume that's some kind of lingo that they usually say to say yes, borrow this every 20 centimeters. Okay, so that was the first one. So let's try, without looking at the notes, try to do exactly the same with the MCY. Being 16.7. Okay. Oops. 16.7. Oh, that's what we did last time. Sorry. Okay, so now we do the. Did I say 27.7? That's what. 27.6 again. Wrongly. 0.6. Let's use that. 27.7. It's funny because I don't want to. I was thinking if I should tell my friend, some stuff. Then I don't want to seem ungrateful. Maybe take it in the wrong way. So I don't know. So that's what I'm not going to do. Okay. So again, so try to remember, work in my head instead of trying to look at the notes, which I've done a lot so far. So 27.6 divided by, so this was the strange, so that would be that one, right? USY in this time, and 0.9, but thickness minus 0.03, and the thickness again was 0.24. So I assume, so let's see, 0.9 times 0.21. This is more or less 27.6 divided by 0.189. 27.6 divided by answer is equal to 146 kilonewtons per meter, maybe. Doesn't matter. Okay, so remembering steps. So again, USY is equal to area of some diameter times 21. So yeah, 146 times that. Okay, now I think I remember. So 146 divided by 21 is equal to that. So 146 divided by 28 is equal to 5.21. So okay, and with the radius of 10, so 0.5 or 1, 0.5, 10 millimeters obviously, but then it should be, it's a centimeter. Okay, so pi times 0.5 equal pi times 0.5. It's obviously the same. So that would be 5.21 divided by, again, 0.785. 5.21 divided by answer is equal to 6.63. So I guess 6.63 plus 1 equal to 7.63. It's more or less, which is more, okay, maybe not answer, which is more or less 8, right? So it would be, 1 divided by 8, 0.125 meters, with the, so 10 diameter every 12.5 centimeters. Meters. Okay, so that's calculate the forces and stuff like that. We have not done that. Should be pretty easy now. Let's do that for fun. So we have 7.21 at 14.3 as a dead load. As a Q, and the the QL squared divided by 4, right? Isn't that the formula? I think so. Yeah, I think so. So 7.1, that will give us 14.3 times 7.21 June. This is the long one, A to B, right? I think it was. Divided by 4. So 14.3 times 7.21 divided by 4 is equal to 105.8. Here, more. Oops. I did do that. And apparently some videos, other videos I saw was this moment was they did this way, but I don't know. The program we used the other way, so I assume it's it doesn't really matter. even though it's positive and negative, you know, so it should probably be that. And for the other one, you know, same formula, but a different distance is 5.15, slightly shorter, 4.3, again, 3 times 5.15 squared, 4 is equal to 4.3 times 5.15 divided by 4 is equal to 94.8 kilonewtons. Not that you should merge them, but if you want. Because they're not in the same place, but still, like, just trying to show that the scales for this one is higher than that one. So I assume what you do later is to see something like MED is more than MRD, maximum resistance, design resistance, and they should overcome that. So with that I end.